Good evening everyone. I am Riya Takwal doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur in the Department of Computer Science and Engineering. Today we are here to discuss the topics of week 12 and after that we will discuss the questions of same week. So first topic is data analytics. So data analytics is a process of examining the data sets in order to draw conclusions about the information they contain. Increasingly with the aid of specialized system and software. So in data analytics, we are going to examine the data, the massive amount of data that is stored in your data sets or in your cloud, and we are going to perform some machine learning models on those in order to draw some conclusion from the data. Data analytics technologies and techniques are widely used in commercial industries to enable organizations to make more informed business decisions, and by scientists and researchers to verify or disapprove the scientific models, theories and hypotheses. So basically this data analytics is used by the researchers and scientists in order to prove or disapprove the various models that are existing, the various theories, and in order to create various hypotheses. Now this data analytics is of two types. First one is your qualitative analysis and second one is your quantitative analysis. So your qualitative analysis deals with the data that is categorical in nature. Basically in case of your qualitative analysis, the data which we have is does not deal with your numbers. Basically it is the data which is textual or in the form of audio or video. However, in case of your quantitative analysis, the analysis which we perform on the data which is numerical. Now qualitative analysis. So the data is not described through numerical values. In case of your qualitative analysis, we are going to utilize the data which does not contain any numerical values. It described by some sort of descriptive context such as text. So the data which we are going to use can be is of descriptive nature, such as your text, your video, your audio, all those things. Data can be gathered by many methods such as interviews, videos, audio recording and field notes. Data needs to be interpreted. So basically the data is not in the exact form that we are going to utilize. We have to interpret the data, we have to extract the information from the data which we are going to utilize for decision making. The grouping of data into identifiable things is done in case of your qualitative analysis. Qualitative analysis can be summarized by three basic principles. First one is your notice things, collect things and think about the things. So in your qualitative analysis, first of all we have to notice the things and then collect the information from the things, and further we have to analyze and think about the things. Now quantitative analysis. So unlike your qualitative analysis, in case of your quantitative analysis, we perform the analysis on the data which is of numerical form. It involves descriptive statistics such as mean, median, standard deviation. So in case of your quantitative analysis, we are going to utilize mean, median and standard deviation. The following are the often involved in quantitative analysis. So first one is your statistical model, analysis of variables, data dispersion, analysis of relationship between various variables, contingence and correlation, regression analysis, statistical significance, precision, error limits. All those are the methods which are involved in your quantitative analysis. Now the comparison between your qualitative and quantitative analysis. So in case of your qualitative data, the data is observed, whereas in case of your quantitative data, data is measured. Further, in qualitative data involves your descriptions, whereas quantitative data involves number. In case of your qualitative data, the emphasis is on the quality of the data, whereas in case of your quantitative data, the emphasis on the quantity. The examples of qualitative data are color, smell, taste, etc. However, in case of quantitative data, the examples are volume and weight. Now, the advantages of doing data analysis. So, data analysis allows for the identification of important trends. So, if we analyze the data, we are going to get the various trends that are going through. We can draw the various information from the data, that which is the trend that is going nowadays. It helps the businesses to identify the performance problems that require some sort of actions. It can be viewed in a visual manner, which leads to faster and better decisions. So the integration of your data analysis with some visual methods will lead to faster and better decisions. It also results in better awareness regarding the habits of potential customers. It can provide a company with an edge over their competitors. So if you are using data analysis, then the decisions which you are making are better as compared to others who are not using data analysis for making decisions. Now, the statistical methods, as we have studied that statistical methods are used in quantitative analysis. Now we will study that what exactly statistical methods are. So the statistical model is defined as the mathematical equation that are formulated in the form of relationship between variables. A statistical model illustrates how a set of random variables is related to another set of random variables. A statistical model is represented as an ordered pair, which is represented as x comma p. So here x and p represent the set of random variables. X denotes the set of all possible observation and p refers to the set of probability distribution on x. So statistical model are broadly categorized as, first one is your complete model and second one is your incomplete model. So your complete model does have the number of variables equal to the number of equations. However, in case of your incomplete model, the number of variables are not equal to your number of equations. So in order to build a statistical model, we need to perform data gathering, and then we need some descriptive methods, we need to think about the predictors, then we need to build a model, then we need to interpret the results. Now analysis of variance. So analysis of variance, which is also called ANOVA, is a parametric statistical technique used to compare data sets. ANOVA is best applied where more than two populations or samples are meant to be compared. To perform an ANOVA, we must have a continuous response variable and at least one categorical factor, such as your age or gender, with two or more labels. ANOVA require data from approximately normally distributed population. Now the properties of ANOVA. So first property is independence of case. So what does independence of case mean? So the sample of data which we are using should be selected randomly. There should not be any pattern in the selection.
Yeah. Well, please explain this ANOVA means. What is the basic concept behind this?
Okay. So basically, in case of ANOVA, we are going to compare two data sets, that which data set is better as compared to other in order to perform your analysis, right? In order to in case of your ANOVA, it is applied. So second statement is it is applied on various samples of data. So it means that we take different samples of data, and that collection of data should be random, that there should not be any particular pattern in order to select the data which we are going to use. Class is in seminar hall. Seminar hall में class. Then ANOVA required data from approximately normally distributed population. So basically in case of ANOVA, when we are going to select the data set, there should not be a particular pattern in which we are going to select a sample of data. So the data should be normally distributed. Now second point is normality. So distribution of
normal distribution means
normal distribution. Please consult your statistics mathematics part. In case of normal distribution, the curve is something like where should I draw? Wait. Curve is something like bell-shaped curve is there. So data is distributed in the form of bell shape, and there should not be a particular pattern in which we are going to collect the data. And next point is homogeneity. So these concepts are related to the statistics of your mathematics parts. So this normal distributed population mean you can go through your this binomial theorem, normal distribution theorem. All these concepts are related to this only.
Excuse me, madam.
Yeah.
From variance, calculation of variance,
Yeah.
what we can conclude after getting the variance?
After calculating the variance, you can get that how much your data is distributed. For example, if the variance value is large, it means your data is distributed. Wait for 2 minutes actually, sir. Class is at 6:30. 6:30. Yeah. So once you calculate your variance, you will get to know that how much your data is distributed. By distributed, I mean that what is, for example, your data set contains the value that lies between 1 to 5 only, right? So the range in which your values lie is not that much large. However, if your data set contains the value that lies between 1 to 100, then this distribution is large as compared to the previous data set. So by calculating the variance, you can get to know that how much your data set is distributed. Fine.
The normal distribution is of the data set, in points of the data set.
On the points of the data sets.
So what do we mean by comparing the data sets? Means and why are we comparing the data sets? For what is the purpose?
See, when we are going to do analysis, we are going to use different machine learning models, right? So for utilizing those machine learning models, sometimes the values which we are taking, the values of data sets or data points which we are taking are not suitable. And sometimes the columns or the parameters which we are taking and the parameters on which we are performing our analysis are not suitable for that particular model. So we have to select that which kind of data is suitable for particular kind of model. So we have to select, see, if you are taking data points that lie only in the range of fixed values, then it will not show the exact data, right? See, consider an example that your data set contains around 1 million data points. You cannot run your models on that much large data points. So you have to take a subset of data from that. If now you are taking a subset of data points whose range lie only within a fixed point, so it will not define your complete data, right?
Yes, means it's not giving a complete idea of the data.
Yeah, it is not giving the complete idea of the data. So we, in order to decide that which kind of subset we have to take, we have to perform the comparison between different data sets.
So basically we will compare sub data sets, different
sub data sets. Right.
Okay.
Yeah. So
comparison can be done with the correlation, no?
Correlation, yeah, this is one technique which is given, that you can also use this. So in case of ANOVA, if we are going to do comparison, then these points we should consider. Correlation you can also use.
Then here it is written that there should not be any pattern, and above it is written that it should be normally distributed. So actually these things are contradictory.
This I need to check, but yeah, whenever in case of analysis there should not be any pattern when we are going to take a subset of data. So this point is perfectly fine, and this I need to check. Actually this thing I have taken from the slides which sir has prepared.
Okay, so means if any of this comes, we have to mark them true.
Yeah.
Okay.
Now data dispersion. So data dispersion is a measure of statistical dispersion. A measure of statistical dispersion is a non-negative real number that is 0 if all the data are same and increases as the data become more diverse. So this is similar to what I have told you, that if your data is same, then the dispersion value will be 0 because data is not diverse, right? However, if the data dispersion value is getting increased, it means the range of the data is more and your data is more diversified. So the example that how to measure your dispersion are to check the range, to calculate the average absolute deviation, variance and standard deviation. You can use any of these techniques in order to check how much your data is diversified.
Data is same means?
Data is same means, for example, the values are same over two data sets which you are taking.
So data dispersion is used for a single data set, or when we are comparing two data sets?
When you are going to compare two data sets.
So if data sets are exactly same,
then
both
the
two data
value
sets are exactly same,
then
the
value is 0. It means the data is not it can also be used in case of single data set also. So if in case of single data set, if all the values are same, for example, you are going to perform some analysis on a particular age of 25, so age group of the people is 25. So in case of age, there is 25. So that data is not diversified. Single value is representing, right? So you can use this dispersion technique in case of single data set also, and in different data to compare two different data sets also.
So like we have 1000 rows, and in all 1000 rows we have age as 25. So
yeah.
In that case, dispersion is 0.
Yeah, right.
Okay.
Now contingence and correlation. So as one of you has mentioned that we can use correlation in order to compare two data sets. So these are the two techniques which we can use in order to compare your data sets. So in statistics, a contingency table is a type of table in matrix format that displays the frequency distribution of the variables. It provides a basic picture of the interrelation between two variables. A crucial problem of multivariate statistics is finding the dependent structure underlying the variable contained in the high dimensional contingency table. So to get the more idea about the contingency table, please follow your mathematics book, that is your statistics chapter actually.
Please give basic idea of contingence.
So in case of contingence table, you are going to correlate two or you are going to compare two different variables, right? So you can take an example that okay, you are going to prepare a matrix, two-dimensional matrix. So if in the row side you are going to put the values of one variable, and in the column side you are going to put the value of other variable. So in case of comparison, you are going to compare whether the two values are same or not. If these are same, then you are going to put 0, and if they are different, then either you can put 1 in order to show that these values are different, or you can put the weight, that how much these two values are different to each other, right?
Okay.
So next is correlation. So correlation is a similar technique in order to compare your two different data set. So Pearson correlation coefficient is a measure of strength of the association between two variables. correlation are useful because they indicate the predictive relationship that can be exploited in practice. Now, regression analysis.
Contingency, it was written, it is related with frequency distribution.
What repeat please?
In first line, contingency table
Yeah.
is a type of table in a matrix format that displays the frequency distribution.
Yeah.
So-
How much? For example, take there is one variable x, right? So this variable, the values of that particular variable may vary, right?
Yes, no, so yes, variable values can vary, but what
Yeah.
is this frequency?
Frequency distribution means how much the value of that particular variable is varying. For example, frequencies, take an example that x can take a value of 5 10 times, it can take a value of 10 15 times. So frequency of taking x as 5 is 10, right? So it is showing that how much a variable is varying.
It is showing variation or frequency. Like, is it like age 25 is coming 100 times, 26 is coming 50 times? So like, it is not showing variation, it is showing frequency.
I'm not getting your question.
Means, is it like we are making a table in which we write age 25 is coming 100 times, 26 is coming 50 times. So if we are making a table like this, so basically it is telling us about frequency. And it is,
Frequency, that how much your variable is varying.
frequency means number of times a variable occurs.
Yeah, frequency distribution is that how much that your particular variable is distributed. What is the exact frequency of a particular value that can come?
So it is not related to means basically variation. Because if I say age 25 is occurring 100 times,
Yeah.
so there is no kind of variation. 25 occurs 100 times. So it is, if 25 occurs more, then variation is less.
Yeah, right.
So in this way we can correlate it.
Yeah,
Frequency and variation.
Yeah.
Okay.
Now, next one is your regression analysis. So, regression analysis is another statistical process which is used for estimating the relationship among the variables. It focuses on the relationship between a dependent variable and one or more independent variable. First of all, you just have to learn these techniques. Nobody is going to ask you that how these techniques are going to work. Because this is a course of IoT and not of machine learning and mathematics. So you just have to learn that which are the different techniques which is used for your analysis. Next point is the estimation target. Regression analysis estimate the conditional expectation of the dependent variable given the independent variable. The estimation target is a function of independent variable called your regression function. It categorizes the variation of the dependent variable around the regression function, which can be described by the probability distribution. Regression analysis is widely used for prediction and forecasting, where its use has substantial overlap with the field of your machine learning. Regression analysis is also used to understand which among the independent variable are related to the dependent variable. Now, the statistical significance. It is the likelihood that the difference is conversion rate between a given variation and the baseline is not due to random chance. Statistical significance level reflects the risk of tolerance and confidence level. There are two key variables that go into determining statistical significance, that is your sample size, that how much data points you are going to take, and the effect size. Effect size here means it is related to the difference between the two different groups that you are going to use. So here it is mentioned that sample size refer to the size of the sample that you are going to use in an experiment. The larger your sample size is, the more confident you can be in the result of the experiment, because as a large sample or as more data points you are going to take, you are going to cover the more number of people on which you are going to perform your analysis, right? On the other hand, your effect size is just the standardized mean difference between the two groups. If a particular experiment replicated, the different effect size estimates from each study can easily be combined to give an overall best estimate of the effect size.
What is effect size? What is the meaning of effect size?
Effect size means you are going to take two different groups of data, right? Two different subset of data. So it's
Yes.
just a mean difference between two data points which you are going to use. For example, in the first data set, the points are 10, 11, 12, right? On the other hand, in the second data set, the points are 15, 16, 17. So standardized mean difference means you are just going to perform the difference between all the data points and find the mean of them.
So what will this give us? Means what will you do after finding?
After finding this,
Mean
you are
difference.
going to get that how much your two data sets which you are taking is different from each other, how the variation in data is going to affect your decision. All these points you can get.
Okay.
Now, precision and error limits. So precision refers to how close estimates from a different sample are to each other. For example, you are going to perform some analysis on a particular set of data, right? And on the other hand, you are going to perform analysis on other set of data. Now first set of data give some different value and other set of data is going to give some other different value. So precision is showing that how these two different results are going to be different from each other. The standard error is a measure of precision. When the standard error is small, it estimates from different sample will close in value and vice versa. Precision is inversely related to your standard error. The limit of error are maximum overestimate and maximum underestimate from the combination of the sampling and non-sampling error. So the margin of error is defined as, so limit of error is the critical value into the standard deviation of the statistic, where your critical value determine the tolerance level of the error. For example, if your error is there should be a tolerance level of error. Basically there should be a range that your error should lie between that particular range. If your error is greater than that particular range, then you have to make some changes either in your data or into your machine learning model which you are going to use in your analysis part.
Now, what is this maximum overestimate that was written? Maximum overestimate and maximum underestimate.
Yeah, because sometime we take data, right? So if we are going to use large amount of data set, then it also sometimes leads to less accuracy. And if we are going to use less amount of data, then it sometimes also leads to less accuracy. So overestimate here means maximum overestimate. Yeah. For example, sometime this do you know the concept of overfitting and underfitting?
Yes.
So this is related to something that only. So if you are if there is overfitting case, this is related to your maximum overestimate, and if there is underfitting case, then this is related to your maximum underestimate.
Okay.
Now the future of IoT applications in agriculture. So how your IoT can be used in agriculture. This use case I have already told you, that you can use various sensors in order to predict that what is the level of moisture in your soil, what is the level of different gases that is required for a particular type of crop, and different and different you can also check whether there are intruders into your fields, or there are some cattle and they can go into your fields. So you can use different IoT devices in order to check all those things. So IoT can be used in order to predict the soil moisture and water level monitoring. It can also be used to perform the automated irrigation system. It also helps in the automation of your recycling, organic waste and vermi composting. It can also do automatic sowing and weeding. Now this AgriSens is a product which is AgriSens is a product which results in which utilize your IoT devices in your agriculture field, which results in more yields and require less water. It saves water and results in a limited water resource in the country. It also results in automatic irrigation and dynamic irrigation treatment in different phases of crop life cycle. It also results in remote monitoring and controlling of your crop. So the proposed architecture is something like this. This consists of your 3 layers. First one is your sensing and actuating layer, second one is your processing layer, and third one is your application layer. So in your sensing and actuating layer there are various sensors and actuators. So sensors are going to sense various variables such as your moisture level, your gases present, and on the basis of those values in the processing layer some analysis is done, and based on that analysis the actuators will perform their function, and all these are controlled with the help of this application layer. Now the design of your AgriSens is consisting of your sensor. So your sensor here in AgriSens, this is a paper. So in this paper they have developed their own sensor node and their own remote server for controlling all these things. Apart from that, the various components that are used in your AgriSens are your sensors and actuators to sense. Further, memory and processing unit that lie in your second layer, that is your processing layer. Then there should be some communication between your sensors and your processing layer and your application layer. So there should be some wireless communication unit, and there is one power management unit which is going to give power to different sensors and different devices that is used in your AgriSens. And this is a picture of the sensor of the water level sensor they have used in AgriSens. Now the emergence of IoT in healthcare. So IoT can be used to collect the patient data. It enables predictive care and helps in understanding the effects of therapy on the patient. So ability of devices to collect the data on their own helps in automatically obtaining data when and where needed by the doctors. It also it also helps in the automation which reduces the risk of error and lowers the error, implies increased efficiency and reduced cost. So what are the different components that can be used?
How error is reduced? Error is reduced.
How error is reduced in case of IoT healthcare?
IoT healthcare.
See, if you are going to use machine learning model, right? So on the basis automation is performed, machine learning model is going to perform all the tasks. Human involvement is less, and as you know that once in case of human involvement the chances of error is large as compared to the automated systems. Fine?
Yes.
Now the components of IoT healthcare. So components of IoT is organized in 4 layers. First one is your sensing layer, other one is your aggregated layer, then processing layer and cloud platform. So sensing layer consists of various sensors, RFID nodes and wireless sensor networks. Then your aggregated layer consists of different types of aggregators such as your smartphone or tablets, which are going to aggregate the data or collect the data from the sensors. Then processing layer is going to perform some analysis on the data which is collected by your aggregated layer, and your cloud platform is going to provide the storage to your data.
Ma'am, for exam, do we need to learn all these layers for everything? Because in this book, almost for everything, many kinds of layers are given. So how are we supposed to learn all these
See,
names of layers?
basically in case of IoT, these 4 layers are compulsory because a sensing layer is the most lower layer which is going to sense the data. There should be something which is going to collect the data, so that is aggregated layer. So by seeing the question, you can predict or guess what kind of layers are involved in that particular kind of application. So depending upon the application, you can do guessing work also, right? Because there are some components that are necessary in case of your IoT. First one is your sensors and actuators. So for that, sensing layer is must. So if there is some question, then it consists of sensing layer, then it should be there, right? So there should be something that is going to collect the data. So aggregation layer is a must. Processing should be done. So you can do guessing work also, right?
Yes, ma'am. Ma'am, sensing layer basically consists of sensor. Then what does aggregation layer does?
Aggregation layer consists of, see, sensor is just going to sense the data. Now you need something that is going to collect the data from the sensors, right?
Yeah, means collect and store the data in database.
Yeah, for example, yeah, you can think like this only, because there are some edge devices which is going to collect the data from the sensors and store in their databases, but their storage is storage is not that much large, so that's why we need to send that stored data to cloud. And also,
Yeah, so ma'am,
yeah,
basically we collect the data by sensor, then aggregate data means basically we store it somewhere.
yeah,
Then
right.
we process, and after processing we are sending the data to cloud.
What
So ma'am,
can you please repeat? I didn't get your question.
first of all we collect the data by sensing layer.
Right.
Then basically we are storing that data in aggregated layer.
Yeah.
And then after whatever data is stored, we are processing on that, and then we are storing on cloud. So I think it should be opposite, like aggregation is on smaller level, then we should basically aggregate whole data in cloud, and then we should process it. So we are processing earlier
See,
and then
this is
storing in
not
cloud.
I'm not saying that this is the sequence of the layers. I'm just showing that these are the layers involved in your IoT healthcare. I'm not saying that.
Yeah.
Yeah. So sometime processing can be done on your some kind of processing can be done your edge devices also. So this processing layer can be on your edge layer also and on your cloud also.
So it
Fine.
depends, order
So
depends.
it depends, right? Because take an example of your vehicular network. So in case of your vehicular network, we need some real-time analysis, right? So we can't wait for your cloud to give the results.
Sensing layer has sensor, so aggregated layer is near the sensor, means basically it is a
Yeah.
device which store data from
Which
4
collects
5.
the data from different sensors that are deployed.
Yeah, means basically sensor from a nearby area. we
Yeah,
can say.
right.
Okay, thank you.
Now remote healthcare. So remote healthcare means so basically your healthcare is apart from the patient, and your doctor is going to analyze or diagnose the patient remotely. So many people without ready access to effective healthcare. So there are various people who are not whose homes are not near to the healthcares. They cannot access the healthcare very easily. So in that case, your remote healthcare is useful. Wireless IoT driven solution bring healthcare to the patient rather than bringing patient to the healthcare. So there are two ways: either patient will go to the healthcare, or you should bring your healthcare to the patient. So it's better to bring healthcare to the patient. So wireless IoT driven solution will do that for you. So it securely capture various medical data of the person, and analyze the data with the help of algorithms and send the data wirelessly or in any medium or wired medium you can use, but it is better to use wireless medium. And your health professionals can give the appropriate recommendation on the basis of analysis which is performed on the data. Now IoT Healthcare real-time monitoring. So this is a figure which is showing that different vital information is collected, and this on performing analysis on these vital information, doctors or the medical officers can give diagnosis to the patients who are who are at remote locations. So IoT driven non-invasive monitoring is possible with the help of real-time monitoring. Sensors to collect comprehensive physiological information, gateways and cloud-based analytics and storage of data is done. Wirelessly send the data to the caregivers, and it also lowers the cost of your healthcare.
Excuse me, ma'am.
Yeah.
Ma'am, one thing regarding exams, ma'am, what are some important topics or topics on which more focus is on there in questions in exam?
That thing I don't know. I didn't prepare your exam.
Yeah, but based on your experience, means basically some topics that are generally asked more or are important.
See, everything related to IoT, I guess weightage is equal. So these questions you can ask in your discussion forum.
Okay.
Yeah.
And ma'am, all question will be single choice in exam, MCQ question.
I don't know. I have no idea. Now next one is your preventive care. So preventing. So take an example that you have to do elderly care, right? So in order to detect the falls of seniors, emergency, in order to detect the emergency situations and to alert the family members, your preventive care can be used. So you can use various kinds of sensors and perform analysis on them in order to detect these falls or in order to detect the emergency situations. Now this is one more product which is generated. This is called Ambusens. So the main idea behind the Ambusens is to do the remote diagnosis of the patients. So in case of your Ambusens, your ambulance is deployed with various kinds of sensors, and some analysis is performed on the data which is collected with the help of those sensors, and the doctor who is present remotely can monitor the patient who are in ambulances. So basically it is difficult for the doctors to go in ambulances. It is not always possible, so that's why such kind of products are necessary. So basically the problem is physical presence is necessary. So doctor should be present in ambulances, but it is not always possible. So the solution for this is to deploy some sensors in your ambulance.
Ma'am,
Yeah,
ma'am, that questions in exam are similar to questions in assignments.
right.
So similar to assignments, right?
Maybe.
Okay, thank you.
Yeah. So emergency response time. So the problem is these ambulances are not always equipped to deal with the complications. So the solution to this is to do the remote monitoring. So basically the basic idea behind Ambusens is to deploy your ambulance with various types of sensors, and your doctor is going to diagnose the patient who is in ambulance with the help with your remote monitoring. So these are the various parameters which is used in your Ambusens. So heart rate is measured, your ECG is measured, temperature, GSR value is measured. Now in Ambusens, the authors have developed their own wireless body area network, and they have utilized different ECG modules in order to predict the heart rate.
What is this body area network?
Body area network means all the sensors which you have applied or all the devices which you have used in on the body of a person. So in case of Ambusens, different types of sensors are deployed on the body of the patient, right? So we are here it is given that in order to predict the heart rate, ECG sensor is used, temperature sensor is used, GSR is used. So all these sensors are deployed over the body of the patient.
Yes, no, but it is written that they are making a network and Bluetooth is used.
Yeah, so basically, so we need to send the data from those sensors, so that's why Bluetooth is used in order to send the data from these sensors to the device which will collect the data. So the device here is a mobile phone which is going to collect the data from these devices.
And then mobile phone will transmit it to the doctor.
Yeah, the mobile phone will transmit the data to the doctor or to the, it can offload the data to the cloud, and from the cloud doctor can fetch the data. Now this is the architecture of your Ambusens. So basically what this diagram is going to show is that different hospitals can fetch the data of the patients who are in your ambulances. So this is nothing, this is the diagram of different hospitals. Here this is a cloud server. Your aggregator will offload the data to your cloud, and all the hospitals or all the doctors are going to fetch your data from the cloud server, and on the basis of that data they are going to do some diagnosis. Now activity monitoring. So wearable sensors have very popular for different purposes such as your medical, child care, elderly care, entertainment, security. These sensors help in monitoring of physical activities of humans also. Particularly in IoT scenarios, activity monitoring plays an important role for providing better quality of life and safeguarding the humans. It also provides information accurately in the reliable manner. It provides continuous monitoring support. So basically you have to deploy various sensors on the body of human being, and on the basis of the data of those sensors you are going to predict the activities of that particular individual. Now the advantages. So continuous monitoring of activities.
No, security. I mean, last slide, security was also written. Security and entertainment. So how a wearable device provides security and how they are used for entertainment?
So for entertainment, basically, okay, you know about AR and VR, right? So in order, do you know about augmented
Yes.
reality and yeah? So
Yeah, VR headset I know about that. They
yeah.
wear.
So if you are going to use some sensors on body in order to get the real feel of particular game where you are where some kind of vibration is there or some kind of pain is there, so you can use different sensors in those things. In games also you can use, right?
And ma'am, for security, how wearables can be used for security?
For security here, variable sensors means ki your data is directly going to be taken from your wearable devices, and it is securely sent to your IoT devices. So there is no physical mean through which your data is going to go through. Everything is automatic. So this is what here security means.
Okay.
So the advantages is through continuous monitoring you can yeah, you can observe the behavior of human. You can check their repetitive patterns of activities through which they are going through. So it results in easy integration and fast equipping. It results in long-term monitoring also, utilization of sensors of handheld devices such as your accelerometer, gyroscope, GPS. These are the various sensors that you can use for activity monitoring. Now these are the various tools for data analysis. So tools are statistical based, your machine learning based, deep learning based. Approaches can be your in place or network based approaches. So in place means on the aggregator layer you are going to perform some analysis, whereas in case of your network based you are going to send your data by utilizing your network, and over the cloud or over the centralized server some analysis is performed. Now the questions. So audio recording collected through the microphones are subjected to quantitative analysis. True or false? So this is false.
Quantitative, false.
Yeah, false.
It's qualitative.
Yeah, audio recordings are qualitative.
Depends on quality of audio. Yes.
Yeah. Second one is a statistical model depicts how a set of blank variable is related to another set of blank variable. So in case of statistical, the relationship is between two different random variables.
Random
Right.
variable.
So option D is correct. Now question number 3, select the statement that denotes example of dispersion measure. So statement 1 is range, variable, standard deviation. Statement 2 is range and average, absolute.
All three.
All three.
No. Wait.
Yeah.
Range, variance, standard deviation is the dispersion.
Range, variance and standard deviation. So which
Yes.
option?
Statement A, 1, A option.
But variance is not here. In statement A, it's variable.
Oh, sorry, variable it is. Okay.
All three.
Then statement 3. Statement
Variance,
3.
standard deviation, absolute, average, absolute. Right. Statement 3, but it is not given. I think
None of
there-
these. Yes. None of these options is there.
Statement 2.
Statement 2 is right.
Yeah. It's dispersion measure.
Dispersion measures means the
How much your
standard
data
deviation,
is
no?
dispersed.
Yeah.
Yeah, standard deviation should be there. I have taken this from your previous year questions. So please check whether this is correct, or I'll check and upload accordingly.
But in the statement 3, the variance and standard deviation is there. That's why the statement 3 is right. Right?
Yeah, right. I need to check this question. A statistical model depicts how a set of blank variable. Wait, this is again repeated. Question number 4 is the different components of AgriSens includes. Options are sensor, actuator, wireless communication unit.
All of these.
All of this.
Yeah, all
Option
of these
D.
is correct. Right. Now question number 5 is the two relevant sensors directly used in agriculture are. Option are soil and proximity sensor, soil moisture, water level sensor, ECG sensor, water level sensor, and fourth
AB.
one. Which
ECG sensor.
one? ECG sensor is used in your medical application.
Yeah, in medical, no?
Right.
A and B is correct, right?
Proximity sensor. Why do you
Oh,
need
proximity is not.
proximity
No,
sensor?
proximity is not
So
required.
it
Option
should
B is right.
be
Right.
Is B is correct.
Option B.
Now question number 6 is the
Why
sensor.
not proximity? Why not proximity? there?
Why do you need proximity sensor in agriculture? For which purpose?
Proximity not required for agriculture.
Proximity is not
It's a
required
medical.
for agriculture.
Medical purpose. It is
Right.
medical purpose.
Medical you can use in case of vehicular network. You can use proximity sensor in order to detect how much far your obstacle is.
Proximity
Yes.
sensor is used to detect something is in nearby or not. So like you said, kettle
For
is nearby
that
or not.
proximity sensor gives you the exact range or how far your that obstacle is. So in case of your agriculture, you don't need to calculate the distance. You just only need to detect whether there is something or not. You don't need to find the distance.
Okay, so some lower kind of sensor we will use,
Yeah,
low
right.
level sensor.
Next question is the sensor node of AgriSens sense the average soil moisture in vegetative phase, reproductive phase, maturity phase, all of these.
All of these.
All of this.
Right. Next is select the correct order of the component layer present in your IoT healthcare. So first should be your sensing layer, then your aggregated layer, then processing layer, and then it should be cloud. However, your processing layer can be present on your cloud as well, but in
The cloud is the last one. Okay.
yeah,
Option A is wrong.
option B is
B.
correct.
Right.
Now question number 8 is which of the following communication protocol is used in Ambusens? So for this question you have to read the paper Ambusens. However, the correct option for this is C. So the communication protocol is IEEE
802.
Yeah.
Point 1.
Question number 9 is wireless IoT driven solution for remote health facility provisioning brings healthcare to patient then bringing patient to the healthcare. True or false?
True.
Right. Next question is the physical activity tracking is a necessary component for activity monitoring, vehicle monitoring, agriculture monitoring, and all of these. This is for
Physical activity.
activity monitoring.
Activity.
Right. Question number 11th is which of the following handheld device are used for activity monitoring? Options are EEG, GPS. This is wrong
C.
because
Option C.
option
Option
C.
C.
Yeah, accelerometer and GPS because EEG is used in your medical purposes. Question number 12 is which of the following is the primary disadvantages of using camera based activity tracking? So accuracy, processing intensive, expensive, none of these.
Is it B, ma'am?
Yeah, it's B.
Processing.
Because if you are going to take images, then image processing is going to be heavily processing expensive. Now question number 13. By performing continuous monitoring of person activity, it is not possible to observe his or her behavior or to identify any repetitive pattern in his day-to-day life. True or false?
It is false. We can observe.
Yeah, we can observe. Question number 14 is which of the following are inbuilt sensors that are present in high-end smartphones? ECG, EEG, accelerometer, proximity sensor, EEG, accelerometer, compass, gyroscope.
C.
C.
Gyroscope.
Gyroscope,
C.
compass, and accelerometer is
Yes,
present in
C.
your
Option C.
smartphones. Yes. Question number 15th is processing the handheld activity device data with artificial intelligence can be used for fall detection, heart rate detection, vehicle detection, all of these. So this is for your fall detection because handheld activity devices are going to predict the human activities. So you can predict fall detection with the help of your handheld activity devices by processing the data of your handheld activity device. So option A is correct for this.
This vehicle detection also can be done with the
Vehicle detection you can how you can do with your handheld activity device?
handled activity device. Okay.
Yeah. So these are the questions. Okay. So I'm terminating this session. I have another class. Okay. All
Okay,
the
thank
best
you.
for your exams.
Thank you. Thank you.
Thank you. Thank you.
Thank you so much.